Hey everyone. Uh, Sorry, I'm having a bit of cough here. Let me share my screen here first. Okay, can everybody see my screen? Okay, just let me know when you guys can see my screen. All right, great, awesome. All right, good evening everyone, and thanks Sue for the introduction. It's 9:10 already, so we'll just start our class from here. And sorry in advance, guys. I'll be coughing a bit here and there, um, having some sudden flu and cough since yesterday. Um, like Sue said, if you guys have any problem or anything that you don't understand or any question at all, just put it in the Discord chat. I will switch my screen every now and then to check the Discord on the chat. Or if you think that I missed your questions or anything, you can just unmute yourself and ask the questions at any time. All right. Okay. So before we start, can I know what is the background of you guys? Now, the reason why I'm asking that is because I need to know if you guys already have some sort of experience in AI, or you guys are like someone who's terribly new at it or just want to learn. All right, so we have one data science here. Are you still a student or are you working as a data scientist? Just graduated. All right, cool. How about the rest? Gen AI Dev. Okay, cool. Fami, can I know how long have you been a developer for? Technician ops, 1 year. All right, cool. I see that most of you guys are still beginners at this, so I think using the slides that I prepared is just fine. Um, okay, I hope you guys can see the slides over here. I think let me just share the slides as well. All right, I'm just gonna put it in the chat over here so you guys can access it as well. Okay, guys. So the class today is called Understanding the Core Concepts of AI. So it's gonna be pretty basics, fundamental, and there's gonna be some mathematics talks involved as well. Sorry guys, I can't help with that. But the essence of this class today is gonna be about um, how to go about learning all of these core concepts and what are those core concepts. All right. Obviously, we would not have time to deep dive into each one of those concepts. We only have 1.5 hours, and to do those deep dives, you need a lot of preliminary knowledge as well, right? So to go through all those one by one will take days or even weeks. But what can I do in this course is to show you guys what are those concepts, how to go learn about them, and how to start, obviously. All right. Um, Hopefully, whatever that you have learned in your university courses or your workforce, you'll be able to use them and connect with what I'm trying to teach you today, and in hopefully in some way they will also make you uh, realize or make you understand something that you did not understand before, right? Now, before we go into further, let me just say a few things about myself, so that you know what kind of questions you might want to ask me later, right? All right, guys. So I've had about 8 to 9 years of experience working as a machine learning engineer. Um, in those roles, I've had a CTO role. I was a senior machine learning engineer. I'm currently a computer vision engineer, But one thing for common is I've been doing AI for the last 8 to 9 years, right? Now, when I say AI, it's mostly about machine learning and deep learning, especially, right? Um, for the first 5 years, I worked in a startup company called Ombre. It's a fashion stylist startup, and then I was also a CTO in that company in my last year there for 1 year, and then I switched to Celcom DG. So I worked at Celcom DG for 2 years, and now I'm currently working at a startup again called Evlos. But during these 8 to 9 years, I've not only worked full time for these companies, but I've also done a lot of freelance jobs for various different companies, both overseas and local. For the overseas, I've also done for a US company. It's a medical startup company. Um, it's called Benefit. You guys should be able to look it up in my CV if you have it. Um, by the way, you can also click this about me, and it will bring you to my CV, and you can see whatever information that you're interested in. And you can also click in on this freelance US company so that it will bring you to the page of the website that I freelance for, right? Um, so again, I've done freelancing for multiple different companies. Um, there are about maybe 5 or 6 Malaysian companies, and maybe 2 or 3 overseas companies, right? And also during these 8 to 9 years, I published 2 research papers for my masters, and in my GitHub, I have about more than 50 personal projects, right? These personal projects are quite random. Some some are made for a certain uh, purpose, and some are just purposeless. I was just curious about them, and I just wanted to go and learn about them, right? And I just go and implemented those algorithms or those projects. So that's about me. Recently, I've also attained a certification from advanced course of LLM from Taiwan, and yeah, that's about it. And let's get right into our course today, right? So these are the things that I've told you just now. I'm just gonna go iterate over them again. Now, before we go any further, we need to get on the same page about a few things, right? Now, the first thing is the concepts. So, what are those concepts? And then, how do we go about learning those concepts, right? I'm pretty sure you guys don't have any problem to find the materials to learn something that you want. Uh, you guys being students and being workers in companies, I have no doubt that you don't have any problem at all to go and find those resources. But the problem here is about finding the correct resources, right? So I'll talk about them at the end. And then that also relates to the common misconceptions. Um, I'm pretty sure a lot of you guys, especially the students, learn things through YouTube, learn things through articles like Medium articles or blog posts like Towards Data Science, things like that. I'm not saying those are bad approach, but they have their own downfalls, and we will discuss about them as well later, right? And of course, avoid getting misguided, because if let's say you're in an environment with 5 or 6 people around you, and all of those 5 or 6 people around you are using um, not so suitable materials to learn about this machine learning or anything related to AI, you're gonna eventually fall into that same pattern, and you're just gonna be the average of that 5 people that you are with, right? We all know that quote. So we are gonna discuss about these 4 things mainly during this course, but bear in mind that I'm not gonna go through them sequentially like how I listed down here. So it's gonna be pretty random. I'm gonna touch number 1, number 4, number 3, number 2, or in any particular order at all. But the first thing first is the concept, right? So we're gonna talk about that first, right? So um, slightly before we go into the concepts of AI, we need to know what is AI and what is machine learning, what is deep learning, and what is Gen AI, right? I'm not gonna go over this in very detailed form, because I'm pretty sure you guys already know about this, but I'm just gonna reiterate this just in case, right? So AI in general is a very huge field. Okay, so we have a lot of different algorithms in the AI field, and the main uh, concept of AI itself is about emulating the human behavior. Okay, doesn't have to be human. It could also be animals' behavior, and it could also be um, anything that resembles to intelligence. Okay, one example that I can give you in AI that is not machine learning or deep learning is is swarm intelligence. Okay, so swarm intelligence is about emulating animals in groups such as birds, ants, fish, um, and whatever other species of birds that work in group to achieve a certain thing. Like for example, a school of fish, right? A school of fish, they always flock together and they always work together to avoid predators, right? And they also work together to find food, um, to mitigate through disasters, and etc etc. And they always do this in swarm. Okay, so this is what we call as swarm intelligence. Same goes with ants. If you guys notice an army of ants going through each other, even though from far it might look like those ants are just hitting each other, but if you zoom in closely, even though there's just so many ants moving around in all direction, none of these ants will hit each other, right? So they know when to stop and they know when to go on their journey. And again, this is called swarm intelligence, and this has nothing to do with machine learning, deep learning, or generative AI, right? So these are AI. Again, AI is emulating the intelligence of animals, insect, or human, or whatever. Okay, so that's AI. Now, under the AI, we have this machine learning subfield. Now, machine learning is all about learning from data. Okay, what is data, what is learning, and all this stuff we will discuss later. Okay, but right now, just think of machine learning as learning from data. That's it. So such algorithm includes naive bayes, linear regression, SVM, neural network, and so on. But here's the thing: the neural network algorithm in machine learning got so big, got so much of attention that it was categorized as deep learning. Okay, so anything that's related to deep learning is always about neural networks, different architecture of neural network. They still learn from data, and they still emulating the behavior of humans or intelligence or whatever, right? But they are this special class of algorithms called neural networks. We will discuss that too later, but for now, let's just think about deep learning as that. Okay. Um, Now we have a lot of different architectures in neural network. We have RNN, we have CNN, we have transformers, we have RCNN, we have spike neural network, and the list just goes on. Now, generative AI, I am confident that it came somewhere around 2015. All right, so um, the first architecture from neural network that was able to generate things was generative adversarial network. Okay, I'm pretty sure the autoencoders and variational autoencoders are also listed down there, but let's just keep it to guns for now, right? So generative adversarial network is the first one that was developed um, to make deepfakes, um, to make all those generated images and so on before the transformers architecture or the diffusion architectures took over, right? Um, so that's generative AI. All right. So I hope from this you guys know what are the distinctions between these things. Now, as we go deeper and deeper, the field gets narrower and narrower, but they are all still under the same AI um, domain. Okay. Now, for the sake of this course, we are going to limit ourselves mostly to machine learning. Okay, because talking about AI will just take too much of time. I'm just gonna touch a little bit about those AI stuff, but mostly it's gonna be about machine learning. Okay, so if you have any questions with that, just ask me straight away. Okay. Sorry about that. All right, so let's talk about the concepts. Before we go into any further, we need to know um, what actually separates AI from other programs that software developers usually write. For example, Android app or web app, um, or maybe even your program for your Windows, right? See, all these programs also looks like it emulates human behavior. When you log into your Facebook, it checks for your password, it checks for your username, and then if it's right, only then you can go in. I mean, isn't that something like human behavior as well, like a bouncer in a club, right? But there's few distinction that actually separates AI from these kinds of traditional programs, right? So these are the ones. First, that program must have the ability to learn on its own from the given samples or data, right? The second one is um, in those traditional programming, like those Facebook login that we talked about earlier, we create the rules, right? So we type the rules one by one. We say that if the username and the password checks out, then do this. If not, then do this way. So those are the rules, right? But in AI creates the rule. All right. Again, when I say AI, we are talking about machine learning. Okay, that creates the rule. And the third one is see, most of those software, right? They fail when the input that they are supposed to receive is slightly modified or slightly different than what they are supposed to be. But an AI should be able to adapt to it. Now, I know that there's a lot of buzzwords here, right? Like learn, data, rules, input, modified input, and so on. So we're going to look into each one of those one by one. The first one we're going to look into is data. Okay. All right. So as for data, um, it can be anything in the format of images, videos, text, even table form, right? Think about let's talk about the table form. So think about two types of variable: hours of study and the test grade, right? So you can see that the hours of study here and the test grade in its separate axis, x-axis and y-axis. So we know that when the hours of study invested by a student increases, their test grade also increases, right? I mean, it's common sense. We don't need someone to tell us. Now, if we were to collect this data, I mean, you go to each one of the students before and after an exam, and then you ask them how many hours you studied, and then you jot that down, and then you get their result. You will notice some sort of pattern like this, right? I mean, it's not going to be straight in a straight, very straight fashion, because there are a lot of other factors involved as well. But generally, you can get something like this, right? Now, this is how a data looks like to a computer. Okay, so when you put in the hours of study and the test grade, it transforms this into a vector space. Okay, now vector space is a bit of a more formal um, term that I'm using here. But if you want to if you want to feel familiar a bit, you can think of this as a Cartesian plane, right? Cartesian plane, sorry. In a Cartesian plane, we always have this x and y. Sometimes we have the z as well. Now, in that x and y axis, we can always plot our coordinates, right? So here we treat each of these data points as one single coordinate, and we're just gonna plot them into a plane like this, right? And when we plot them like this, we will be able to see the trend or the pattern over here. Now, this can be done for any kind of data at all, okay? Not only just for tabular data. Tabular data is the easiest for me to visualize over here, so that's why I did it that way. And other types of data is a bit harder for you to visualize, so I didn't not I didn't I voted against it. So think of images. Images are made of pixels, right? So each pixel can be plotted in a Cartesian plane, but just that each pixel will have their own axis, right? So perhaps the x-axis is about the first pixel, y-axis is about the second pixel, z-axis is about the third pixel. Now, in an image, we might have like thousands of pixels, right? So where are we gonna go for the fourth axis, fifth axis, sixth axis, and so on? We need 1,000 axes, right? And that's why we need vector space. A vector space can have any number of dimension, right? With any number of axes, in other words, right? So that's why we convert them into vector space, and inside that vector space, each individual pixel will have its own value. Okay, so we call that a multi-dimensional space. Okay. Now, same goes with text. Like let's say words, king, queen, um, man, woman. Let's say. Now, if you're able to convert these words into some sort of vectors, king and king and queen will always be slightly together, whereas man and woman will always be slightly together because they mean certain, because they mean the same thing or similar things, right? Whereas something totally different, like let's say rocket, would be very far different from these four. Okay, so that's how data is represented in vector space. Okay, now I hope that clears up some things. Um, in for some of you, it might have evoked more questions, but you can always ask me those questions. Okay, I'll be happy to answer. Now, now that we know what data is, right? Again, data is represented in a some sort of a coordinate kind of a plane, right? Now we can use that to find our rule. Okay, now um, see, there's a trend over here, right? We know that the more the hours of study someone put, the better their test grade is. Okay, now if we can somehow find a line, okay, that cuts through them in an optimal way, I'll talk about the optimal way later. In an optimal way, we will be able to predict on unseen data, right? Like for example, let's say your sample with those students when you did the survey only had 10 hours of study. Now you want to know what happens when a student put in maybe 20 hours of study, or 30, or even 100, right? So you want to know whether students who put in more hours will have what kind of mark would they get, right? So you want to have a guess. Now obviously for this kind of use case, the mark doesn't get above 100, but let's say we do have some sort of scaling that is above 100, right? So we want to know what happens when our x-axis goes further. So to do that, we create our rule first, right? And then once we have our new variable, we can put inside that rule to find our y. That's it. Simple as that. See, y equal mx plus c, I know you're familiar with. Pretty sure you can't pass your SPM without knowing this, so I'm not gonna explain too much on that. All that I'm gonna explain is that this is an equation to get a line. M corresponds to your gradient, C corresponds to your bias or your coefficient, right? And X and Y is your input. So when you want to have the so-called rule, you can always substitute whatever input to your X, and based on the rule that you have created here, rule here means basically the value for your M and C, you will be able to get your Y. So your input will always correspond to some sort of output depending on your M and C. Alright, so this is practically what a rule is in machine learning. It doesn't matter what kind of algorithm you're using, except some probabilistic algorithm, probably like naive Bayes or something. You will not be able to you will not be able to escape this particular equation, right? So y equal mx plus c. But of course, since like I said earlier, all this happens in a vector space, we named the m as w, the c as bias, right? Weights and bias, right? So I hope that clears up something to you as well. I'm pretty sure you guys have heard this word weights and bias a lot, but maybe you don't know what is that. Well, basically it's just the coefficients. All right, so using the weights and bias, you find um, you find a line that fits your data point like this. See, probably this is the best line that it could be fitted in this data, but there's maybe different ways of fitting your lines as well. Okay, so now that's rule. Guys, give me 1 second, I'll be right back. Let's go. Sorry guys, had to go take some water before I choke on myself. Um, so let's see if by far there's any question. All right, so far no questions. Um, okay, so that's about the rule that I was talking about. Now let's talk about learning. Okay, so I did mention to you guys, it must have the ability to learn on its own, right, from the data. Now we already discussed what is data, we already discussed what is rule, so let's talk about learning, right? See, if I were to ask you in scenario 1 and scenario 2, which one has the best line, you would probably pick the second scenario without a heartbeat, right? You know intuitively this is better than this. Now, if I were to ask you why this is better than this, do you have any answers? Does anybody want to try? Hmm. Okay, I guess everybody's quite shy to try. I saw Fariha was typing something, but she changed her mind. That's fine, no worries. I'll tell you guys the answers here itself. All right. Now, okay. So now we know that the second one is better than the first one because the line on the second one is much closer to all the points here, right? I mean, it cuts through those points instead of this. The points are somewhere far above the lines, right? Now, mathematically, how do we want to tell that this is better than this? We use something called loss function. Okay, now I know this looks scary, but it's something not hard at all. It's actually something that you probably learn in your high school. See, y1 is your data points, and y1 hat is your predicted. Okay, so it could be the other way around, doesn't matter. Now, the predicted are the lines, right? And the target is the blue dots over here. Now, to find the difference, we basically just minus them off and then square root them. Yeah, sorry, square them. And the reason why we need to square them is because it'll cancel off any kind of negative values over here, and it will also make it easy to differentiate later. We don't want to talk about differentiation yet, but just think about the squaring as taking off those negative values if there's any kind of negative, right? um, you can ignore this part for a while now, and the summation basically just sums up all the points. That's it. So it starts from the first point all the way to nth point, right? Now, when you apply this MSE on the first one and the second one, obviously the first one gonna be very high, right? Because the points are very further apart from the line that we draw. But in the second one, it's gonna be very small. So that's how we know which line is the better one. Okay. So now that we have all right. So now that we have data, and then we have a rule, and now we have a way to figure out which scenario is the best when we draw a line. Now we go about learning it, right? Now this involves a little bit of calculus, so you don't have to get overly um, scared about these things. Again, these are something that you have already learned in your form 5 or form 4 probably, right? In your additional mathematics or even in the calculus subject in your universities. All right. So what gradient descent actually does is basically when you have your error loss over here, when you differentiate this error with respect to your x1 or those coefficients earlier, right, m and c, you will be able to get some sort of graph like this, right? Now, when you get a graph like this, you will be able to know in which direction you should change the value for your graph to go down. Now, at the further down it goes, the lower the loss is, right? So that means you are adjusting the weight, the W, such that such that the line gets closer and closer to all these blue dots over here, right? And the way you do it is basically you get that old value minus with the partial derivative of this guy with respect to your W, right? This A over here, the alpha over here is just a learning rate. Basically, it's just a constant. Normally, we just set it to 0.1 or 0.01 just to make sure that when we go towards a certain direction in this graph, we don't jump too high, right? So that's just a constant right now, right? So basically, that's about it. So you have a rule, you have your data, and then you have your rule, which is y equal mx plus c. If you want to convert it to linear algebra, it's basically, um, sorry, it's basically y equal wx plus b, okay, weights and bias. And the w can be a matrix because you can have multi-dimension. And about the learning part, we basically learn through using a error function. In this case, it's the mean squared error. And we apply our gradient descent on the error function to slowly reiterate multiple times to get a line that best fits all the data over here. Now, that's basically all the concepts that you need to know about AI. Okay, um, I'm not saying that this is all there is. There are still a lot of others which I will show you now. But in essence, if you don't know anything about AI, let it be this takeaway. Okay, um, it these three things. All right, so it must have the ability to learn from data. Now we already looked at what data is. Okay, now we already looked at what learning is as well. So learning is just basically applying those gradient descent on your loss function, and you keep on reiterating those weight values and the bias value so that you reduce your loss. All right, um, and here, as you can see, it's using the data to create the rules. And here the rule is nothing but finding the coefficients to your weights and biases. That's it, right? There is no fancy rules, if else, no such thing. Unless you're talking about three decision model, that's a different thing. But in most cases, no such thing. It's basically just the coefficients. Okay, now about the third point, right? I told you guys earlier that most traditional software fail when a slightly modified input is given, but an AI wouldn't fail. Now, what I mean by that is, see, let's talk about our data again, right? So in our data, we have this hours of study. Let's say you create a rule-based algorithm here. So if the hours of study is 8, then you'll get 80 marks. If the hours of study is 10, then you'll get 100 marks. If it's 4, you'll get 60 marks. So let's say you set rules like that. Now, let's say there's another input like 4.5 or 5. You never set any kind of rule for this. So how does your your software gonna adapt to this? It can't, right? It's just gonna give some sort of error. But if it's an AI, it's a line. It works on all the values here, right? So even during the training data, this one particular data over here, let's say x equal to 6.5 or whatever, doesn't exist during training. But because this line is continuous, right? When you put 6.5 over here and then you just put the m and c, you will get your y. That's it. It's still able to predict, or it's still able to give you uh, a good guess, right? Instead of saying error or say giving you something that's irrelevant at all, right? Now, I'm not sure it will work on all instances. Maybe if you give something that's like way too big of a number, then it's gonna give you some sort of nonsense, like how ChatGPT hallucinates from time to time, right? But in general, it works better than a traditional software in this kind of scenario. All right. Now, last but not least, let's talk about how to go about learning all these concepts, and let's do a little bit of discussions on those things that I've discussed earlier, right? Okay, so far no questions. All right, guys. Now, I told you earlier that learning through YouTube and Medium blog posts are not very effective. Um, I'll tell you why. The reason for that is because, um, see, a YouTuber most of the time just wants to increase the view counts, increase the subscriber count. So for that, they're just gonna resort to a lot of fancy gimmicks, um, to show you that things can be explained in a very simple way, just to get some views, right? Um, I mean, of course, not all YouTubers. There are some good YouTubers which I will name later, but most of them are that way. Now, same goes with all those medium blog posts or the towards data science blog posts. They mostly do those things for views and for subscriber counts, for collabs, and for you to go through their paywall, right? Now, I'm not saying it's wrong to go and learn from them. Those things should be used as a supplementary, right? See, when you learn something quite well and then you forget about it after 3 months or 4 months, you just want a refresher, then you can go and learn from that. Now, the actual way of learning things is must be through the mathematics, right? Because machine learning is full of mathematics, you can't escape it. If you really want to be good in machine learning or AI, you have to know the mathematics and you have to put in the effort. Now, I'll give you some example. Let me start with some of the easiest one. Okay, so I wanted to learn about naive Bayes last time, right? So what I did, I went and studied my probability. Uh, Bear in mind that I've already studied some mathematic books, linear algebra, calculus, and some few probability books as well. Now, using these things, I derived this algorithm, right, from scratch, and here you go. So this is your naive Bayes algorithm, right? And then we have the rule. You can check on this code on this blog post to get additional explanation on it, but I basically just picked the equation from there, right? So I got this equation from scratch. I derived them, and once I have them, I went and implemented it using nothing but uh, pandas and numpy, right? I didn't use any kind of sklearn naive Bayes. I only use this to do the train test split. And when I tried to implement that from what I've learned, it turns out to give me a very good accuracy. Let me see what accuracy. Yeah, 99.79, right? So from there, I know that my implementation is correct, and my understanding on that is also correct, right? So if my implementation didn't work, that means something is wrong, either with my understanding of the algorithm, the way I derived it, or my implementation itself got some sort of error, right? Now, once I know about the simple naive Bayes, I went and developed Gaussian naive Bayes. See, once you learn the first step, the second step is normally easy. So the first to learn about the naive Bayes took me maybe about 1 day, and to learn about the Gaussian naive Bayes took me just few less than an hour, right? Because there's nothing much that's been added on top of it. It's basically uh, dealing with continuous variable, whereas the naive Bayes only deals with discrete variables, right? So those are the only two difference over here, and you just had to add a few more things over here, and that's about it. I implemented that again, and again I got accuracy of 71% over here. Now, the SK learn version gave me 82% instead of 71%. And when I looked into it, the scikit-learn version of not Gaussian naive Bayes has has a bit more implementations inside it to make your algorithm a bit more accurate. That's it. So they just added a few things over there. But other than that, everything else is very much the same, right? They did some modification to the original algorithm. Now, that's basically how I go and learn about it. Now, if you ask me how I go and find those reference, it's mostly through research papers or through university notes. Okay, I'll teach you how. So, for example, let's say naive Bayes, right? So what you want to do is just put site edu at the back. Now, when you put that way, when you're googling or using whatever search engine, see, most of the result that you're gonna get is from universities. So this one is from CMU. This is from Stanford. Let's see a different one. Cornell. There you go. See, they do all the derivations over here on this or even this. Say, normally what I will do, I will pick, I'll just go through like maybe 5 or 6 of them. I'll just glance through, and then I'll pick maybe the maximum 3 of these materials. I'll read all 3 of these materials, and then using my own understanding, I'll come up with my own notes. All right. So, give you one example as well. Let's say Kalman filter, right? So, have you guys heard about Kalman filter algorithm? No? Alright, I'm gonna take it as a no. So I'm pretty sure you guys have watched movies where a fighter jet plane follows another fighter jet plane, and then the missile, the pilot will aim for a missile lock, and once the missile lock is activated, they will launch their missile, and the missile will be able to follow the target and hit the target, right? That's Kalman filter, basically, right? Um, Another example that I can give you is your GPS. See, when you're using your GPS and then you go inside a tunnel, a huge long tunnel, you might lose your network every now and then inside it. But even though your network is lost, your GPS, your Waze, or Google Maps will still be able to give you some sort of an accurate prediction on where you are, on your speed, and on the estimated time arrival. And that is also using Kalman filter. So in other words, Kalman filter is this algorithm that can use your previous movement or your previous state to kind of predict your future state with very minimum uh, dependencies, right? Now, I would say that this is one of the hardest algorithm that I had to learn. Right, I don't know why I can't open it in GitHub. I'll just download and show you guys over here. All right. Okay, so as usual, I always start from problem statement, and then I will get some sort of initial initial equation from the problem statement, and from there you derive one by one. And you know, you put in those logics one by one. What do you want? What do you don't want? And then you figure out using your mathematical skills. Or see, minimizing the estimation error is still the core concept that we discussed earlier. You minimize and all, and finally, this is what you get. So there are 5 different equations in Kalman system, and it's a regression process, obviously. So one try to do the update, another one try to do covariance update, another one try to project into the future time step, another one calculate the errors, and then it corrects its error using some sort of learning concept that we discussed earlier, right? Now, after all of this, I went and implemented the Kalman filter, and you'll be surprised that the implementation from scratch is only about 5 lines of code. Now, obviously, you can there's more lines of code here. Sorry. Okay, while it opens, I'll tell you guys how I went and learned about Kalman filter as well. Now it's the same thing as I showed you. I if I'm not wrong, I learned this through MIT. Yeah, this is the one. So this note helped me a lot on this. Here you can see the same thing over here. But again, like I said, I read from uh, few different websites, and then I try to put them all together into my own notes, like you saw just now, right? Now I'm not sure why this thing is not coming to Python notebook. But anyways, it's the same as the naive base that I told you guys earlier. Once you know the mathematics, and once you know the concepts, you'll be able to convert those into the codes. You will be able to implement them and to verify them on your own, right? So that's the kind of approach that I would normally go for when I want to learn something. Now, obviously, when I'm learning all these tutorials over here, sometimes I might not understand what these people say, right? Sometimes a word is too hard. Like, for example, maybe let's say, yeah, maximum likelihood. You don't know what is this, right? So then you go and Google up for what is this thing, and then you try to learn about that, and then you try to learn about that that you don't understand from there, and you try to write them up. And when you do it this way, it makes it easier for you to learn something else in the future. Okay. um, Normally how I would do it is I use Obsidian. So in no way I'm promoting this app, guys. This app is free anyways. So it's an open source. I'm not sure if it's open source or not. Anyways, the way I do it is, let's say for example, I need to figure out something about IEEE 754. Okay, so I'll open up a note, and then I put whatever I need to put over here, and I learn about that, right? Um, and then I put all the references here. Same thing with a lot of other different nodes. I'll put it there. Now, once you have enough nodes, when you look at them in a graph view in Obsidian, you'll be able to see all the nodes over here and how are they connected to each other, right? So for example, um, row major versus column major. So this is related to linear algebra, data engineering, and contiguous memory. So when I click that, I go to this contiguous memory and I will be able to see how that relates to this, right? Uh, sorry. Um, yeah, I've only started to use this like less than a year ago. Previously, before that, I used to write down in papers and they always go missing. So that's why I had to resort to this. But yeah, basically, that's how you do it. You learn the concepts one by one and then you put them up together. Sometimes it may take a very long time for you to learn an algorithm this way. So do it at your when you have a free time, and you should start as early as possible, because by the time like maybe 3 or 4 years in the future, you will be able to learn like, I don't know, like 20 or 30 different algorithms that are very useful, and you will be able to learn them in a very deep manner. Okay. Now, this is not for everyone. I understand that. You don't have to probably go into such depth, but you have to know that this thing exists. Okay, so that's the whole point of this 1.5 hour class. I'm just showing you guys that this is the depth that you should go if you want to be really good in what you in AI or in data science or whatever, right? Because if you just learn things to tutorial, okay, let's see about uh, neural network, right? See, we have. I'm pretty sure some are good, but I'm pretty sure not many are as good as what it should be. Hopefully, I don't have to pay anything. So, guys, it's good as a refresher. Okay, see, until here, that's it. It's not even like one page of a paper, right? And most of the time, they're just showing you some fancy picture and then showing you neuron and what's not, weights and all. But they're not showing you what is those weights, what is those biases and all. So you'll not be able to understand anything when you read this kind of articles. I used to read this kind of article, and when I don't understand, I used to think that I'm the one that's problematic, but it's not, right? It's just that you are looking at the wrong piece of information over here. uh, of course, if you understand the mathematics and all, and then you want to come to have like a flow of story in your understanding, then you can come and read about this kind of things. I bet this is slightly better. Yeah, this is slightly better because at least they show all the weight matrix, the input vector, and all. Yeah, but still, it doesn't even go over a few pages. Now, in my GitHub, I also have a neural network nodes. Over here. Okay, so again, start from dataset and problem statement, and here, when you go inside the perceptrons, it always starts with mathematics, and I'm now using the perceptrons as logic gates. This is a different way of looking at the neural network. Also the same thing like earlier, but again, this is multidimensional. We have 3 dimension over here, z, x and x, x1 and x2 instead of just 2. And uh, I got all this different uh, information from many different sources, put them all together, and finally, once I've learned about all of this, I was able to build a neural network from scratch, right? Again, this thing's not working. I don't know why. It's only 9.3 KB. Okay, so this is what I wanted to show you guys. You should learn it this way. You should learn from research papers. You should learn from those edu websites. Put them together, make your own notes, and then go and implement them without libraries. Now you don't have to do that for every single algorithms. Only do that to algorithms that you think will be very useful in your career, right? I think I've only done that for like maybe 10 to 15 algorithms. I didn't do it for any other algorithm. After that, like for example, I have this latest one, mass auto encoder PyTorch. So this is a self-supervised based learning. I got it from this paper over here. So, and I wanted to implement it, and I read this paper and I implemented over here, and I didn't implement from like super scratch as well. I did have some reference. I used PyTorch, the framework, to implement it. I didn't use like NumPy or anything. There's just no purpose to do that, right? Unless I want to do some reverse engineering and stuff like that, that's a different story. But in this case, no, because I really want to implement this algorithm and I want to see how well it works. And indeed, it worked quite well. So that's how I normally go about it. And if you guys are wondering how you want to look for research papers, you can also go to Google Scholar. Okay, so let's say you want to look for convolutional neural network. See, you can't put tutorial for many of the things, but only for some they have the tutorials. See, like in this case, the Stanford University does have a tutorial on deep learning. Over here, I'm pretty sure this is also not very complete kind of tutorial, but at least it's a good starting point and it's more reliable. And they have all these references over here that you might have to go through later on, right? Unlike those Medium articles or YouTube tutorials that shows you half-baked information. Now, you could probably go for a bit more different as well. Yeah, but also in research papers, there are also a lot of frauds. Okay, and I would advise you to avoid IEEE unless you are really needed to go find a paper there. but try to avoid IEEE. There's just too many uh, bad papers lying around there, right? Yeah, I think this is better. See, you have a whole paper written for your convolution neural network, and this is the way that you want to learn things more properly. And again, you don't have to rely only on one node. You can find multiple nodes and then figure it out. And this is from the Nanjing University in China. uh, so I would say this is more reliable than any kind of tutorial that you will be able to find online, right? Okay, so far you guys got any questions? All right, one person asked, do you mean we should know how to work out algorithm from scratch before we just... Okay, good question, Fariha. See, I'm not saying that every algorithm you need to know to be able to implement it from scratch before you just blindly implement it from library. You can do those blind implementation from library, but you need to know that there's massive limitations when you don't know how those algorithms work from scratch. Okay, I'll give you an example. um, so let's talk about CNN, right? How familiar are you guys with CNN? Convolutional neural network. If no answer, I'll take it as a no. Okay, just the basic concept. All right, cool. See, the way the CNN works is by using... All right, cool. Uh, is by using filters, right? So I'll show you guys how the filters look like. I hope I have my other class. Hey, maybe on second day. Okay. I hope this code still works. Okay, so CNN learn things by filters. Okay, filters just basically some array of numbers that applies to your pictures to make it look like this. See, for example, this is my original picture, and then when I apply a blur filter, it makes the cat picture blur, and when I applied a sepia filter, it makes it look very glowing. This is an emboss. It gives a 3D feeling, and so on and so forth, right? Now you also have the edge detections, like this one. It detects all the edges, and so on. Now, okay, see, the same way goes um, for any kind of images that you give, right? The filters will look for certain objects inside that images, right? Now, when I was teaching this class to my other students, what we did was we used these 10 classes. All right, so there should be more classes here. One of those classes is garbage truck, right? Like the one that I showed you down there. Now, what happened was, in most of those garbage truck photos, a garbage can was beside it. All right. Now, one of those filters, when we tried to visualize it, I think I can't show you guys here because it was saved here and it's now missing. But what happened was, one of those filter learned to detect the garbage can in order to identify whether there's a garbage truck or not, right? Because most of the training data consisted of this garbage can, right? Now, luckily for us, there were a lot of other filters that were detecting, like the tires, the back part of the garbage truck, the drivers, the windshield, and so on. But imagine for a second that all of the filters learn to look at this guy to figure out there's a garbage truck. And then now in when you deploy this algorithm in real world, right, there is no garbage can. Now your algorithm is not going to work, right? That's because, again, the rule that the algorithm came up with based on the training data is, if there's a garbage can, then there's a garbage truck, right? See, if things go wrong like this in production, and mark my words, it will. All right, when you're working on machine learning projects, most of the time, 50% of the time, your project will go wrong. I would even go as far as saying that 80% of the time, something will go wrong when you put in production. If you're working in very critical sectors like healthcare, military, or uh, something that has to meddle with life of people, you're gonna have to be held responsible for when things go wrong, right? Especially if you're in a very high position in those projects, like a lead or a project manager and so on. So if you do not know your algorithms well, when things go wrong, you would not be able to fix it rather quickly, right? You will just be you would just be since you're just meddling with libraries without knowing how those algorithms work, you're not going to be able to stand on top of the problem as soon as possible. I'll give you an actual scenario that happened recently, right? So in 2022, I think earlier than that, 2020, during the COVID time, a lot of big companies, big names, even universities, every one of them, they just try to jump at the opportunity to develop an AI model that detects COVID using the CT scan of chest, right? Now, again, bear in mind, these are done by prestigious universities and companies, okay? So these are not just some normal developers, okay? These guys know how the algorithms work. Now, when they did that, um, most of their data comes from the same hospital, okay? Because there was only few hospital in that area. I believe it's in US. So they all took just from few different hospitals. One of the hospital being the biggest of them all. And when they took from that hospital, what happened was a lot of those patients who had COVID had difficulty breathing, and therefore when they were doing the CT scan, they lied down, okay? They were lying down on the bed when they did the CT scan. Those people who didn't have COVID didn't have the difficulty breathing, so they chose to stand up when doing the CT scan, right? Now, there was a very subtle difference in those CT scan that shows whether a person is standing up or sitting down or lying down, right? What the algorithm did was it figured out who was lying down and then marked them as having COVID. It figured out who was standing up and marked them as not having COVID. Now, these people were in a rush to develop a model. They didn't test well. They straight away deployed it. During the testing, all of them achieved super good accuracy, 99, 99.9, and so on. When they deployed it, it performed super badly. It was like 50% random, right? Now, when they looked into it, it didn't happen to only one of them, it happened to multiple different prestigious organizations. Now, of course, because these people are very capable ones, they were able to figure out what was the problem very quickly, right? They got the domain expertise, and they figured out rather quickly how what was the error in this thought process, uh, and this error finding comes from your understanding of the concepts and the concepts of the algorithms, right? Now, if you didn't know how CNN works, right, you didn't know about filter, you didn't know about anything, and you just simply mine hantam from the library, you just put a bunch of framework, put a bunch of codes there, and then you train your model, and just because it outputs 99% accuracy, you put it in the production, and something like this happened. How are you going to answer that? And most importantly, how are you going to fix it? How do you know where to look to fix it? You wouldn't. That's the issue, and that's the limitation that I'm talking about. Now, I'm not saying that everyone must go and learn from scratch like what I did over here. I just want you guys to know, though, this thing exists. You don't have to go that deep, but you do have to know at least linear algebra, right? Now, linear algebra is not a very hard subject, and a bit of calculus. That should be good enough. And at least try and learn more. Try to be more inclined towards learning the mathematics part of it. You don't have to go from scratch, but you can always find other mathematical terms from different sources and piece them up together. You don't have to write notes like what I did also. It's fine, right? If a machine learning model isn't giving good result, how long do you think it's worth exploring improvement before considering to move on? Okay, that's a tough question. See, the way I would do it is by first looking at the data set, right? Uh, okay, let's talk about images because those are easier ones. Um, so let's say you have a bunch of classes, 10 classes, uh, and you think, okay, assuming that the data are all good and clean, right? So there's no mislabelings in the data and all, right? And when you train a CNN model on it, you expected, let's say, about 90% or something accuracy, but you're not getting good accuracy. Now, when you know the theory behind CNN, and when you have enough experience and intuition on CNN, you would know um, whether this problem is solvable or not. Okay, now the rule of thumb with CNN or any other algorithm of machine learning is that if a human can do it, then the machine learning can do it. All right, so let's say you are trying to detect some sort of stain on papers, right? Now, if you show a human two different images of the paper, one with stain, one without stain, and if a human can easily identify, oh, this is with stain and this is without stain, then your CNN should be able to figure it out as well. If your CNN for some reason is not working, then you have to upgrade the architecture. You have to probably add more layers. You have to maybe add more data, uh, add some sort of other strategies like dropout, regularization, uh, layer norm, and so on. There are like so many different things that you can try. Now, when when you have tried all of this and it still doesn't work out, then you probably have to go back to the data, right? I'm pretty sure dropping the project itself is not something that you want to do. So if that's something that you can't do or don't want to do, you have to go back to the data. There was probably some mislabelings in your data. There's probably some sort of anomalies in your data that's causing it. It happened to me recently as well. Um, I took the data from a friend and then I tried to train a model from it, and the model was performing well on training but not on the test. I kept doing it multiple times and it's still giving me the same thing. When I looked at the data itself, I myself couldn't categorize the data because they were all very confusing. So that's the issue sometimes, you know. You have to go back to the data to find out uh, what's the issue. I hope that answers your question. Um, but if you ask me personally, how long do I think it's worth exploring? That depends on the timeline. If the timeline is quite a lot, I would say you can just explore as much as time allows. But if the timeline is like maybe 1 week or less than 1 week, I would say whatever that you have right now, keep it as a backup, and then you do more and more, right? So if those things you do more fails for whatever reason, at least you have a backup. That's how I would do it. And you deploy that first as a version 1 or version 0.5 or whatever, and then you ask the manager or you ask your project manager, whoever, for extra time. Tell them your justification why this failed. Again, that comes back to the understanding of the algorithm, right? Or in this case, you can use your experience. You can tell them, uh, okay, it didn't work so well, maybe because I didn't try this, I didn't try that. You ask them for like another 1 week or 2 week and tell them that you want to try this or you want to try a different strategy and do it that way. See, there's no need to panic when things don't go right? You are still a beginner, you are still a fresh graduate. People wouldn't put too much of pressure on you to make things work unless they are toxic, right? I hope that answers your question. Anybody have any other questions? Okay, if there's no question, I just have one last thing to share with you guys. Um, right, the YouTube tutorials. Now, I did tell you guys there are some YouTubes that are uh, YouTube channel that are good, and one of it is this Deep Lizard. So I've seen her tutorials, bits and pieces here and there, and she does a very good job in explaining how things work. So I'm just gonna copy and paste it over here. Now again, you shouldn't use this as your main source of knowledge. You can use this as a supplement. But then if you don't have time to go and learn about those algorithms like the way I told you to, then no problem. You start with this first, okay? Again, those things that I told you guys earlier about learning things through mathematics is not a must. It's a good thing, a very good thing if you can do that. But I do realize that not a lot of people would have the same amount of time, same kind of schedule that I have, and therefore you can't go and learn those things with your time. By the way, it took me a long time to do those as well because I was doing them quite slowly, and I had a lot of other things going on as well. And luckily for me, it was MCO during that time, so I had quite a lot of free time on my hand when I wanted to learn those things, right? Um, Deep Lizard is good, and then three blue, one brown, also good. Three blue, one brown is this author is from I believe he studied from Harvard or MIT. I'm not really sure. So he's an actual mathematician. He's legit. I believe that his channel is one of the best in YouTube to learn all about deep learning and about mathematics itself, right? Sorry about that. Um, yeah, that's about it. Um, and last thing that I would want to say to you guys is that um, this is not a solo game, you know. You would actually learn a lot better if you have a group of people that you can learn with, right? So try to find a community. I would say Crenovator is a good start. Try to find other people who are interested in machine learning and try to keep in touch with them, and um, perhaps you guys can learn together, share each other the knowledge, make a study group or something, and through that you'll be able to learn even faster and more effectively. When I was doing it, I unfortunately did not have those study groups that lasted very long, but I did have bits and pieces here and there with a lot of different people, and I wouldn't lie, those things actually helped me a lot, right? And as for books, I would give you this one book. Uh, yeah, there you go. So you guys should be able to download this. How do you feel about using AI tools like ChatGPT for learning programming? To what extent do you think we should rely? Okay, good question. Uh, Definitely not 100%. All right. See, you're talking about programming, not machine learning, right? When you want to learn about programming, sure you can use ChatGPT. What I would suggest you to do is to make the learning fun using ChatGPT. How I would do that is, you see, recently I wanted to learn about Rust, RUST. It's a programming language. When I looked online for Rust tutorials, most of the projects were boring to me, right? It's just basically command line interface, bookkeeping, calendar, time trackers, and so on. I wasn't interested in those. I wanted to do something more interesting. So when I couldn't find those tutorial, I went to ChatGPT, asked me to write a tutorial on those using Rust, with that specific version of Rust, and what kind of tutorial I want. So for example, I think I did a I forgot what I did actually. I think what I did was a predator prey model simulation, which was kind of interesting to me. It's just basically a simulation that runs to show how much the population of a predator will go ahead of the prey if the number of prey is too less or the number of prey is too high. So that was quite interesting to me. I gave the details to ChatGPT and asked it to write a tutorial. Now, the first version of code that it wrote was full of errors when I run it. Those errors I pasted back into the ChatGPT. Then I got a better version and better version until it works, right? So once I know that code works, then I go about copying the code one by one and investigating each line of code. What is this? What is that? Why not this way? Why not that way? Now those kind of questions you can ask ChatGPT. Okay, you ask ChatGPT, why are you using this particular type of variable and not that particular type of variable? What's the difference between them? And then when it gives the answer, you can probe even further. So again, don't rely 100% on ChatGPT. When it gives you the answer, you go Google on your own, try to find a different version of answer. Now this entire process will take much more time, obviously, but trust me, you will be able to learn much more deeper and in a more satisfying way like this, right? Now rather than go and find some tutorial online that you think is boring, you can use ChatGPT this way, or at least that's how I'm using it, right? If you already have a tutorial that you find online and it's quite fun, then sure, you use that code. And when you don't know a certain, when you are not sure about a certain keyword that people are using on the tutorial, then ask ChatGPT. Okay. All right. We got 4 more minutes. Do you guys have any question? All right. I think most of you guys are very very shy. Um, okay. There is one more book that I also forgot. This one is about deep learning. See, again, you don't have to read these books from scratch or anything like that. You can always refer back to them when you are unsure. Let's say in your company you are about to use naive Bayes, right? All right, you never heard about naive Bayes. For the sake of your company, for the sake of the timeline, you implement the naive Bayes, you give it to them. But when you have the time, extra time at home or whatever, and you have your curiosity, come and read these books to learn more about the naive Bayes to see how you could have done it better, right? So that's how you actually learn. I learned through making a lot of mistakes as well. Um, and there's obviously one more benefit that I forgot to mention to you guys about learning things this way. um, See, when you learn things through mathematical way, you would be able to create your own algorithms in a novel way, right? So you don't have to always depend on something that people already made and some tutorials that are already out there to solve your problem. For example, when I was doing the US project, I was tasked to um, to come up with an algorithm to detect whether an infant, a baby, has cow milk protein allergy or not, right? Cow milk protein allergy, call it CMPA. Now, the way that the cow milk protein allergy is tested is by a very inhuman trial whereby the babies are given both the milk without the cow milk enzyme and then milk without with the cow milk enzyme. They do this trial for 2 weeks and then they see how the baby reacts to it. And if the baby has allergic reaction to it, then the baby has basically allergy towards CMPA. And if not, means the baby is healthy. That was the trial they were doing for many years on the CMPA. But what happened was I was tasked to figure out if there was another way of doing it, and the doctor in my team told me that in during his 20 years of experience, he found out that the babies with the allergy actually moves a bit more erratically. He can't explain it mathematically, but it's based on his intuition. So then we embarked on this 1 year project where we where we had data from the doctor on babies with the allergy and without the allergy, and I had to use existing post estimation algorithm but modify them heavily, right? Now for those modification, I needed a lot of mathematical knowledge that I had today, and once I modified that, I had the post estimate, uh, the poses of the baby. Now, once I extracted the poses, I had to calculate kinematics. Now, during this kinematics calculation, it required me to do a lot of things that nobody had done before, right? I tried to find in research papers, in tutorials online, and there was nothing like that. So, in the end, I found another research paper that was doing something similar but for a different disease. So, I was able to modify that to calculate the kinematics, and turns out the doctor was right. Babies with the cow milk allergy has a little bit of variation in their movement, right? And using that data that we had, um, we were able to train a classifier to identify whether the baby has a allergy or not. And the model yielded about 75% accuracy in most cases. And again, that was just a prototype model. Um, I did the project for a big pharmaceutical company called Reckitt. They did it and make it as a research as well. Um, so yeah, that's just me sharing you guys with the benefit that I had of learning things from scratch. It's not necessarily useful anytime soon, but it will be definitely be useful in the long run, right? Um, yeah, that's about it. I see no one has asked any other question. All right, so I think we can end it here. Thanks a lot, guys, for joining the late night Friday class. I hope that you guys have fun learning. If you guys have any question, you can always PM me, or you can just ask in the group as well, right? So if I'm free, I'll be able to answer to you guys, right? All right, guys. All the best in your journey, and good night, right? No worries for me. No worries for you. Happy weekend, guys. Bye.